cause contamination inside the Earth's crust. In fact, here is dating of individual felspar grains from rocks in in central parts of Australia that actually give argon ages up to over 9 billion years because of having extra argon in them, inherited in them. Here's an example here in Colorado, in fact, where a granite had intruded into schists, other crystalline rocks, metamorphic rocks, and what had happened is that the heat and the fluids from the granite actually perturb, change, make the ages in the surrounding rock younger. When you go out several miles from this granite, the age is around 1,200 to 1,400 million years. The age of the granite is supposed to be about 100 million years or less. And see what happens. The heat and the hot water from the granite has actually changed the ages in the surrounding rocks, brought them lower. So heat and fluids have actually perturbed the system and caused contamination.
Was the new rock absorbing argon and strontium?
No, because the water flow was out of it.
Okay.
So the heat and water was coming out of it. So the flow was away from the younger rock into the older rock. And you can see for up to 1,000 feet, there was significant reduction in the potassium argon ages and in some of the rubidium strontium ages on some of the minerals in the surrounding rocks. So you can imagine that's heat and hot water has altered these ages. So what's going to happen to rocks that are in the ground for a long time when geologists aren't there to monitor that nothing has happened to cause changes in the ages over the supposed millions of years? In the same situation here in Colorado, now we're looking at the uranium, lead and lead ages, and again you can see they're significantly altered by the heat and the fluids from that granite. This is one of my favourites. This diagram and several related diagrams are in the first rate book. This again these are all examples out of the conventional scientific literature. This is not results produced by creationists. So I'm just demonstrating that this is well documented in the scientific literature, the problems with these methods. In this instance, they took individual crystals of a mineral that they could date using uranium lead dating by shining a beam of ions, a beam like electrons, onto the crystal surface of a flat surface of this crystal. They found that if they changed the angle of the crystal so it wasn't perpendicular to the beam, they perturbed the age of the crystal by several hundred million years, just by changing the way the beam shined on the surface of the crystal.
What kind of a dating method is that, using a beam?
It's called the ion microprobe. And the most sophisticated version is called a shrimp, and it was actually, the technique was developed in Australia at the Australian National University in Canberra. It stands for a sensitive high resolution ion microprobe. Rather than electrons, you shine a beam of ions, ION, onto the crystal surface.
So do they think that's a good method of dating?
Yes, it's actually the most used method now. You may have seen in the literature where they've supposedly dated zircon crystals up to 4.2 billion years old from rocks in Australia. It's by using that particular method. Okay, and you can see in the same laboratory that method was developed, those results came from that same laboratory that I just showed you. If you want the reference, it's in the first of the technical volumes of the rate research. Here's an example. of granites. Now, granites have a number of minerals in them, and one of the minerals is the mineral zircon, which you've heard about from Russ Humphreys. Okay, it's zirconium silicate, and it's a mineral that doesn't usually melt. It's a very high temperature mineral. It's found in sediments, and sediments can melt to form a granite. And so if you've got zircons in the original sediment, they won't melt, and often the radioactive clock will not be reset. And so what you've got is a Himalayan granite that's supposed to be 21 million years old. It gives uranium-lead ages of up to 753 million years because of having inherited these zircons from other sources. In a southeastern Australian granite that's supposed to be 426 million years old, you get uranium-lead ages up to 3.5 billion years because of contamination of the granite with these supposedly old zircons. Similarly, in New Zealand, you get uranium-lead ages of up to 1638 million years, then a granite's supposed to be only 370 million years old. And you also, monazite is a phosphate mineral, but it has uranium and thorium in it. And you can actually get negative uranium-lead ages in a Himalayan granite that's supposed to be in a monazite grain, a negative age, a granite that's supposed to be 20 million years old that gives a zircon age of 1483 million years. So the monazite gives a minus 97 year age, and the zircon gives a 1483 million years age.
So the negative age means it won't be formed for 97 million.
Correct, that's right. And this is actually part of my own research that I did when I was working with the mining company that brought me here to Denver in 1981. They owned the uranium deposit on which I did my PhD research. And I was doing this research with one of Australia's government agencies, research agencies, and we were looking at soils. And of course, the soil over the uranium